Assalamu alaikum. This is Digital Logic Design Circuit Lab. My name is Syed Muhammad Fakisha, and today I have to make logic circuits, logic gates. There are actually seven logic gates. They are shown in this figure. First one is NOT gate, AND gate, no OR gate, NAND gate, NOR XNOR. This is not an exclusive or exclusive NOR. So I have to design these logic circuits of these gates, and I have to show simulation of this that I have to give the input and observe the outputs of the circuit. So I will simulate these gates in Proteus. So I will be opening Proteus. So this is the interface of Proteus. I'm opening new project from here. So the name of this project is Logicgates. For sheet. Yes, now we are here in the project. I'm gonna search for the components I need. So I'm gonna design the AND gate, a circuit for the AND gate, and the AND gate I have is 7408. So yes, this is schematic model. Okay, then I'm gonna search for two switches. Switch. Then I'm gonna search for the resistance of 100 ohm. And I'm gonna select for resistors. So this is a resistor. I'm gonna select, and then I have to search for LED. LED. And the LED I'm gonna use here is this one. After selecting the components, I'm gonna place these components and this. I'm gonna place AND gate. Here I'm gonna place LED. Switches, two switches over here, and resistor. I want resistor. Yes, here it is. I'm gonna connect them. And the reason I'm placing the resistor over here is because if there was any noise in the circuit, it gets grounded immediately. So this wire is placed wrongly. Now it's right. And then I need two DC surge inputs from here. And after doing that, I need ground. Right, so this DC source is of 5 volts, and this is also 5 volts. So let's see how it works. So I'm going to simulate it. So as you can see, nothing is happening, and no LED is glowing because both the gates are open. So if you see what AND gates is, so in AND gates, when both inputs are open, the output is 0. And when one gate is closed and other is open, the output is still 0. And similarly, the third case is, and in the fourth case, when both the inputs are closed, gates are closed, and both inputs are 1, the output is 1. That is, both will be glowing. So here it is. So if I close one, nothing is happening. Open it, and close this one, nothing is happening. So if I close both, you can see the LED is glowing. So this is working nicely. So okay, and so I made this all the gates like this, and I'm gonna simulate it likewise. Just you have to change the gates in the circuit, and everything else remains the same. So in this case, if I show you AND gate is done, and if I show you this NOT gate, here it is. So the NOT gate, we see what happens is not in NOT gate. There's only one input and one output. So it actually inverts the input to its output. So in now when I simulate it, uh, yes. So when the input is 1, the output is 0 in NOT gate, and when the input is 0, the output is 1. So it's showing greatly. Okay, if I move towards second or third OR gate I am having over here. So in this gate, what does OR gate do? OR gate actually adds do addition process a plus b. So what does it mean is when both the inputs is 0, the output is 0, that is not going because the inputs are not given, there is 0 input voltage. So if only one of the input is 1, the one of the input voltage is 5 volts, the bulb will be glowing, and it will be glowing. And similarly, and the third case is when B is 1, the A is 0, and the X is 1. So in the fourth case, in the last case of the OR gate, when both the inputs are 1, that means when both the input voltages are given, the output bulb is glowing. So let's see how it works. So in now both the inputs are 0, so the bulb is not glowing. If I close one of the gate, you see the bulb is glowing, the LED is glowing. So if I open it and I close the second one, still the LED is glowing. And similarly, in the fourth case, when both inputs are 5 volts, the bulb LED is glowing. So moving to the next one, and we have NOR gate. So let's say what an OR gate is. So a NOR gate, yes, in NOR gate, when both the inputs are 0, the output is 1. What does it do is it is a NOT gate on the head of the input of OR gate. So there's an OR gate attached to a NOT gate, uh, or the NOT gate attached to a output of the OR gate. We got the NOR gate. So in NOR gate, we have when we have both the input 0, in OR gate it should be 0, but after inversing it or inverting it, we get 1. So let's see how the simulation of OR gate works. So in NOR gate, we have both the input 0, the output is both the input 1, and the output is 0. So when I open it, nothing happens, and when I open both. So in Norgate, I'm having over here is after running the simulation, you can see that both the inputs are 0, output is when the, sorry, in Norgate, when you can see over here when both the inputs are 1, the output is 0, and if I open one gate, still the output is 0, and if I open both the gates, you can see the LED is glowing. So and the next gate I'm having over here is Nand Gate. So in Nand Gate, we see first see the logics of this table of this gate. So in Nand Gate, when both the inputs are 1, the output is 0 because there is actually a NOT gate on the output of AND gate. So in simulation, we can see when both the inputs are 1s, the output is 0. So if I change one of the inputs, the LED should glow. So that one, you can see over here, the LED is glowing. So when I open both the gates, still the LED is glowing. So it's working perfectly. So in exclusive NOR gate, if you first see its truth table, in exclusive NOR gate, you can see that when both the inputs are 0, the output is 1, and both the inputs are 1, the output is 1. It means when both the inputs are similar, the XNOR gate will be showing us 1, which means that the LED will be glowing. And when there will be dissimilar inputs, the output will be 0. So here we can see they are dissimilar inputs. The LED is 0, and if I change the dissimilarity, still the output is 0. So if I make the input similar, that is now 1 1, the output is 1, and if I make the input 0 0, the output is 1. So the last gate I'm having over here is XOR gate. So in XOR gate, or exclusive OR gate, it does when the input are similar, the output is 0, and when the input are dissimilar, the output is 1. So in simulation, we can see over here the inputs are similar, then the output is 0. If I change similarity to dissimilarity of the inputs, the LED is glowing. And if I make similar open inputs, the output is like 0. So it's working perfectly. And that was all from this lab of digital logic circuit design. Thank you.